Good afternoon to all of you. Oh yeah, I love you all. I love you all. You know, last 2 days we've been talking about innovation, sustainability, the future of autonomous. Even the topic of this entire engineering summit has been sustainability through autonomous future, etc. So what we thought in this session, what we'll have, how are we seeing innovations happening in the automobile space, in sustainability space, in autonomous space? Before I start deep delve into the topic, perhaps I will love to get from Debashis and Thomas, if you can take a few minutes and define how do you see an automobile industry from a consumer commercial car perspective in the next 5 years? How did it look like? Apple has already gone on and said is an living experience with the iPad with 4 wheels, right? So how do you see where all the things going to change?
So basically, the car will be really IoT on wheels, as we say famously. But more than IoT on wheels, it will get connected to the ecosystem, whether you call vehicle to home or vehicle to grid. So vehicle will become part of the ecosystem, whether it is the grid or home or the Internet of Things. This is how I look at it. And the business will change. The business of automotive companies will no longer be making cars and servicing cars. It will be providing a lot of services along with the car and more customizable products for the end customer. And it will get connected to the ecosystem, as I said.
Thomas, your initial comments?
KSV, I like your opening question. I met a few years back with the Renault CEO, and at the time they created this vision of a car that gets better every day. And we're all in this industry, we love the product. The product is an identification, the product is passion. In many markets, people love motorsports, people really identify themselves with the product. But then we have the challenge that with the unification of powertrain and electrification, a lot of that differentiation gets basically lost potentially because all cars kind of behave the same. They have a big battery, they have one or two motors typically, and they have a big punch when you floor it, which is great, but where's the differentiation? And I think that's where we as an industry have really a chance to drive differentiation and help our OEM customers, help our suppliers really create products that are enjoyable. We've seen at the Munich Auto Show, BMW presented its Heart of Joy. Heart of Joy is basically an ECU, which is ought to show up in a keynote, but at the end of the day, it's a software-defined solution which brings the whole passion of driving of the brand into a software solution, and that's our opportunity to really help our customers drive innovation and differentiation.
Yesterday we were talking offline on the car space. Why is it standardization is not emerging so strongly in the automobile industry, especially when you go to the EV side on the battery charging? Tesla won't collaborate with rest, and rest of the people do not have a same charger. Where do we get the moment towards standards in automobile in terms of EV charging?
It is a race, and the best system will win. And we've seen between May and July a tectonic shift in one of the key markets in North America. In basically an Earth slide, the whole solutions for charging electric vehicles converged into one proprietary solution, you may say. So basically all car makers, except for a few that are not decided yet, have given up their existing charge solution and went to the Tesla system. Why? Because they realize that when it comes to mobility, having disruption is unacceptable. And the range anxiety which was followed, initial range anxiety which was followed by the charge anxiety, is limiting the scale of this mobility solutions in EV. And the only ones who have put out a sustainable, available solution that is convenient to use, it's plug and charge from day one for 10 years, was Tesla. It was a big investment. And now out of a sudden, that investment is monetizing for them massively. They're tapping into 8 to 10 billions of US government funds that they're getting back by opening these charge point networks in the US. And that's a huge boost for them. But that's only the beginning. Some of you may not realize, but Tesla is on the journey not to be a car maker. Tesla is on a journey to become an energy company altogether, because they're connecting the value chain from generation through solar all the way with distribution, all the way to consumption. And that gives them all together a really unique solution. And many players in the industry completely underestimated the importance of having a completely seamlessly value chain for its mobility products. Now they're trying to catch up with this. So it's a learning for Europe. If you try to take a road trip in Europe, you're touching 5, 6, 10 countries within a day easily, and try to charge your electric vehicle in those countries. It's a very disruptive experience. It's very frightening with the range anxiety.
Debashis, your comments. Renault is also in the fast-moving car space. Any reason you say, for example, in mobile, a handphone said either you have an Android or an iOS as a platform is generating volumes. Many companies, the automobile companies, are creating their own operating system for various interfaces. Do you think that innovation towards a common standard is an opportunity available for us to innovate?
I think the opportunity is shown by the Chinese market, because if I see China has standardized the middleware. So I'm just trying to say the software-defined vehicle, how China is doing it. The middleware is standardized, and then there are lots of component and software components which gets plugged to this standardized middleware. And the sensors and other controllers are also in sync with the middleware. So then they make something which the iPhone does or the Android phone does, that with the same hardware, you're able to upgrade from one iOS 11 to iOS 12. If you talk of standardization, the China market is a good example. And frankly speaking, in Europe, common standards could not be evolved. And that's where the European OEMs are a little bit struggling compared to their Chinese counterparts, who are highly standardized in terms of software-defined vehicles.
Fantastic. On that note, let me start with the first one, the innovation. We talk about sustainable and materials. In your opinion, with the stated goal of all of us going green, carbon emission savings, etc., what are the innovation, it is happening, or should we be innovating to leverage more components and materials that could lead to sustainable, reusable, recyclable elements? Debashis, your comments on that.
I think very relevant question in what the sustainability goals which are there for each of the industries, and if our products are not sustainable. So a lot of innovation is happening as I speak to you. When you talk of car, the parts inside the car, one big thing is the first step was to make use of recyclable materials. But no longer all car makers are more or less using recyclable materials. But the point is, how much of the parts inside the car are using recycled materials? And that's the big change which is happening. Recycled materials, if you talk on an average, the cars will have 20 to 30%. That means a huge scope is there to go in percentage in terms of the recycled content inside the car. So I give you an example of recent launch of a Renault Scenic, which has about 25 to 30% recycled part inside the car. And the second innovation which is happening is to use biomaterials. That means how we can use natural fibers and then use it in the composites, which is comprising of the dashboard, the door panels, the seats, etc. Then going away from leather and going for other type of materials for the seats. Even in the electric motor, going from permanent magnet, which has a lot of rare earth materials, to go for a synchronous motor, for example, or for a battery, going for low carbon battery. So such innovations are happening so that the carbon footprint to make those parts are reducing. Process side also, if when you make the cars, we are going for recycling of the plants. One of the good example is one of the Renault plants, Flan, in France, is taking all the cars which have end of the life, they go inside the factory, they give a second life to the cars. This is unthinkable in automotive industry, and it is happening. And then whatever is coming out of the car, for example, a battery is coming out of the car, there is a second life for the battery. How it is happening? Because you refurbish the battery, and instead of using in automotive, it is used in stationary applications. So a lot happening in terms of business models and material science for sustainability in automotive engineering.
Is the ecosystem also participating in the sustainability
Really?
material discovery?
Exactly.
Okay.
Exactly.
Thomas, your view.
Kesri, I think the biggest challenge for every player in the industry is to become net zero with its production by some year in the future. Some say 2030, some maybe push it out to 2040, but ultimately across your supply chain to get to net zero is a huge, huge endeavor, and it requires significant investments, not only by car makers or truck makers, but a whole supply chain. What is really helping us on this is, of course, we touched on a few points of sustainability. Vegan leather, just from an end user perspective, has been introduced into cars in the 2015 years, where first car maker introduced animal-friendly products, and that appeals to a certain amount of users, which is increasing. And we see this today as a mainstream. We see it in the new BMW 7 Series, which comes with a non-animal friendly leather options, unthinkable in the previous generation. When we look into process innovations, just in the last 10 days, 4 major car makers, I start with Toyota as number 1 globally, Ford, Hyundai, and there was a third one.
Renault, Nissan.
I don't believe so. We're switching, at least publicly, we're switching their manufacturing process of cars to an entire new way of constructing cars. I'm not sure if you're aware, but Toyota had completely stopped its current MEB platform, electrical platform, and had to go back to the drawing board on thinking how they would assemble cars. And this leads to a technology innovation that comes from the process and from the tooling side, which is gigacasting, basically creating large, huge 1.5 meter wide aluminum casting parts with presses that push as much as 15,000 tons in the future, which is a hugely impressive but also a very delicate technology. If you look at Tesla's 4680 cell rollout, which is hugely delayed, the process innovations that are coming with this, taking a lot of refinement. So I think the industry is now really at the point where they need to combine the mass capabilities of these productions with also the yield that comes out of these processes to really be mass production ready. Cost reduction has a lot to do with the expectation of customers how big a battery has to be in a car, and we unfortunately see this trend of 100 kWs, 150, 200 kW batteries, which is a little bit counterproductive when it comes to actually the sustainability of the product and the cost. So building affordable cars, that is one of the big challenges, and I know it from our conversations with Renault particularly, who have a strong play across Europe and other markets with affordable mobility products. To produce a $20,000 or $25,000 electrical vehicle within whatever is deemed acceptable range is one of the huge challenges the industry has these days, and has to do with the availability of charge point networks, the investments that go into this. And I see us in a position as engineering providers to really help drive these innovations and accelerate these journeys. These journeys don't have much time to wait, as it takes decades to transform.
Interesting you say this. People of my generation, of course my generation is outliers now, we always thought car as a mechanical device. Mechanical device, I continue to believe whatever all you may say, it remains a 4-wheel and steering for me, that is important to me. How are you not transmitting the vision of automobile going for sustainability materials into the ecosystem? Perhaps the young boys and girls pursuing their academic program in the colleges, are they thinking sustainability in automobile industry, what is going on? Are the academic institution gearing up to think materials is a key component? Or, I'm not being derogative here, are they still producing the software engineers without the, how do we create the software engineers more knowledge on, say, standards in automotive, say standards in sustainability material coming in, all those aspects. How do you think this collaboration could work, that all of us collectively to create a vehicle, even in the context of what we had with the conversation with Ms. Mukundan, sustainability is emerging, software is driving the car, India is a software powerhouse. In sustainability, and yesterday we heard again, sustainability is easily achieved with the technology focus. If India really plays a card well, sustainability, technology, software, etc., we can lead the world. For leading the world, collaboration and community interaction is important. It will be good to know what is it, what are your views, Debashis? How is that collaboration, community development, and academic institutions, research institutions happening to build it? What should be done and what could be done?
Very relevant question, because India is known for IT and IT services. And it's our strength, no doubt. Now it is digital, which is taking the next wave of India on the global map. But when we are heavily digitalization across the industry, and we are also known for software, one should not forget there is a huge, as Thomas said, sustainability goals. Every industry has to reach zero net carbon by 2050 or 2030 or 2070. So we need a lot of core competence like material science, mechanical engineering, hardcore tech, electronics engineering. And I think we as a country should recognize the fact that we need a lot of engineers, fresh engineers, feeding software, feeding digital, but also core technologies. And we should not be blown away with this digitalization and software wave and not be cognizant that there's a lot of work on sustainability which need core engineering. So my humble request, I think a lot of Gen Z, and we had a session in the morning with young engineers, do not forget core engineering and core science, because this is very important. The jobs are there, lot of opportunities are there, especially in automotive industries. We still need designers to work on platform, chassis, upper body, material science, and there is a huge future for you. Don't just get swayed away in the wave of digitalization and software development, because there is lot of opportunities there, equal or even bigger opportunities, because we have high sustainability goals. So this is the message I give to my teams. This is the message I give to the academic institutions, and I think the source of motivation and inspiration for anybody studying mechanical, electric, and electronics, that there is a huge scope in the future. Don't try to change your jobs or change your streams.
Thank you, Debashis. Thomas, I want you to disagree with what Debashis said.
Well, my father used to be an electrical engineer, and actually he was very familiar with power electronics at the time for the company he worked for. But that was a discipline which between the 80s and maybe the 2000 years was completely pushed to the background, because nobody was really interested in innovations around power electronics. But with the rise in electrification since the Dieselgate that we've seen in maybe 2016, power electronics is a huge discipline which requires decades of experience sometimes in engineers to understand how we can optimize power electronics to move the envelope of electrification. And performance improvements in electrification that are only 0.1% or 0.2% can mean a significant impact on the overall economical balance of a product. So that's one area to call out as an example. The other example I want to call out is just a data point. A vehicle today, a regular 2023 model, has probably around anywhere from 80 to maybe 120 million lines of code. 120 million lines of code in a car compared to a passenger airplane like an Airbus 320, which sits around 10 to 15 million, is a hugely complex product. And people are often scared to make changes to this. But the changes is a constant thing. Think of the market leader today in this space, Tesla. Tesla changes its software in the product, the invisible part, basically every single minute or every 10 minutes. Tesla moves software in and out that is invisible. It's not the update where you have to press yes and wait for 20 minutes or so. It is constantly moving software around between its vehicles, because its vehicles are active in the market, contributing to create better software. So it's basically a software-defined product that helps to get better as it is being used. That's also why Tesla took another approach. Tesla put in a supercomputer in every car, irrespective of a customer paying for that hardware. That's unthinkable in traditional car makers. Only if the option has been paid for by the customer, you would get the supercomputer. But in that case, they turned it around, and just by using a product, you're contributing to the software journey of the particular product. And that's an approach that really needs a different mindset in software engineering. The predominant language of coding that we're using in automotive embedded technologies is 40 years old, nearly 40 years old. The second popular one is about 35 years old, C and C++. When we're forcing our engineers to learn these outdated coding techniques, we're putting them on a career path that is not beneficial for them overall. We're selfish if we do them for C and C++. So an innovation approach was to really open up how embedded software can be created using modern coding techniques like Rust and Go language, for example, as skills that were previously unthinkable in the automotive branch. So these are innovations that we're pushing and still maintaining the safety and the security of the product that is absolutely non-compromisable. So these are innovations that we see beneficial for the young talent that comes now from colleges. Here at Wipro, we have about 20,000 every year that are joining us as next-gen associates. We don't want to push them to learn C and C++ necessarily. We hope that we can use them, let them use cloud-native coding techniques, which gives them a fruitful career path.
Just for the audience, we had our internal discussion with the leaders on what could be the next course of program in engineering colleges. We would soon be announcing, perhaps coming out with perhaps not only for the existing students, the colleges, perhaps all of you are interested in reskilling, upskilling, a deep learning program in automotive electronics and some of the deep core engineering that is required for us to sustain on that. We'll come back to you on that. Watch out for our announcement. There should be very soon. The third aspect which is important, I presume, it is so, it is not presumption, the automobiles are getting safer. Automobiles are getting safer, secured. How are you now building different customer experiences? What are the trends you're seeing in the customer experiences and safety and security? And linked to that, notwithstanding what you said, Debashis, don't get carried away with digital engineering, etc. Technologies like AI tools, how are they being utilized to bring better customer experiences? Can you share? I share that. Start with you, Thomas, and I'll make Debashis disagree with you.
Yes, so I can give you, I think, a really easy example out of my personal life. Whenever I bought cars that had modern assistance technology, that started back in Germany around 2005, my car had an adaptive cruise control. I gave it to my wife, let her do a test drive, said, "Here, honey, I paid a lot of money, when you try it?" She came back after 10 minutes and said, "I don't like it. I will never use it again." I said, "Why?" Because it does not drive like I would be driving. It behaves like a synthetic system, like a robot, and I don't want to be honked at, unless you're in India. But in these markets, she doesn't want to drive like someone who is just not blending in. And over years, whenever I had a new car, these assistance systems were not to the level that it passed my wife's test. And there, even up today, my Tesla does not pass my wife's test. But I have hope, because I know my Tesla is learning how she is driving, so it learns how to blend in. And this brings me to AI. So how do we bring context, intent, and the assimilation of human behavior into a product that learns to blend in and not be synthetic? It does not feel alien to me. And that's a huge opportunity, and we can do this by constantly assimilating how a person, as an example, is driving. But that requires an extra investment. Guess what? Tesla put an extra chip in that is not being paid by the customer, that learns in shadow mode. That shadow mode is why the system can learn how I'm driving, because it compares its robotic driving with my human driving. Assuming the human is right, it will drive like the human eventually, learning it in the back end. So this is where we see AI become one of the really large opportunities. The scale of what we're talking, I want to just do a raise of hand. Who in this room heard of Project Dojo?
One hand.
One.
There. Two hands there, yeah.
Two. That's interesting. So Project Dojo started at Tesla in 2021, creating a super chip, the size of a waiver, so it's like a record-sized chip, that was putting their AI acceleration capabilities together and has been moved into a computer system beginning of this year and is now being deployed. To put this into perspective, Tesla deploys in the next 12 months the capacity of the equivalent of the annual manufacturing output of NVIDIA to 60%. 60% of NVIDIA's enterprise production of accelerator card is installed just in Tesla's servers, in Tesla's data centers. That costs you on market prices around $10 to $12 billion in hardware if you were to pay for that. Tesla is paying less than $1 billion for that because they designed it themselves. And they're going to use this to work through the data that comes from their product to really train their neural models, which is hundreds, at the scale and the speed that is needed to make this product at the scale of a 5 million and growing fleet of cars really work like the human intention is to assimilate autonomous driving in certain markets. And that's an opportunity, and we see the scale of AI is being driven at this level. Other car makers would not even benefit from this compute power because they wouldn't have the feed of data that they could actually reinforce and learn from. So that's the advances in AI are determining how the product is really feeling in the future.
So Devash, I don't want you to contradict what he said. I completely agree with you.
No,
I know
this
you
is-
also agree.
This is a typical OEM and partner discussion. I fully respect that we have to meet the customer expectations, and I think I start from where your first question was. It is the internet on wheels,
Yeah.
IoT on wheels, and basically a software-defined vehicle allows a lot of customization to happen. And thanks to this, just like you have an iPhone and you can download features, so on demand you can have features on your car. But as Thomas said, due to artificial intelligence, the system also says what are your preferences, and based on your preferences it will configure the car. The digital display on the car gets configurable to your tastes and your habits. So like that, lot of artificial intelligence will help us to make the car customizable, and you can also download features from the cloud on over and above it to have an excellent car experience in the future cars. So this is something which is going to happen in a couple of years.
Again, I said I come from an outlier generation. Tell me, if I buy my car new car in any case due to buy, what will the experience look for me? It will certainly pass my wife's test for sure, because she doesn't know how to drive. But having said that, you tell me, what are the experiences we can look forward to in a car in 2025?
I think when you sit in a car, on a lighter note, each one of the family members will have its own experience inside the car. You will have a lot of features where you can use your car journey in a good productive way. That means you are not just traveling inside the car, but you can do a lot of other tasks inside the car. So as the productivity of a person can be improved, thanks to that journey, which you can do a lot of other things inside the car by connecting to the cloud, and plus you are safe, secure, and you have a great experience because the car experience is customizable with your taste. So this is how I see the car in coming years.
Fantastic. Any one or two questions I can take for the panelists, if there is one? Yes, sir. Two questions. I'll go at the back and come to you. Yeah, just go there.
Yeah. So I'm Yuvraj. So we speak about
He's done a Google
SDV.
search on both of you, whether you're done speaking truth or not. Yeah.
So now my question is related to this SDV and the software development that is happening in OEM. So and we quote everywhere Tesla on this because there's a good benchmark where everywhere it is. They speak about Tesla. So here the scope of tier 1 industry, what is the exact plans that presently OEM has with respect to tier 1 industry is my question.
Is tier 1 ready, geared up to match with your future domain changes?
Yeah, that is one thing. Second thing, if most of the softwares are done at OEM level, what is the expected deliverables from the tier 1 industry then?
See, the SDV, the software-defined vehicle architecture, the key aspect is you are segregating the software and the hardware with the middleware. So I think with the complexity which is going inside the car, the work which we do with integrating the tier 1 technology, whether it is a brake or a steering, etc., it will be much better than what we are today, right? So we will be able to configure in a better way, and we'll be able to put all the legal stuff like data security, data privacy needed in order to have a faster time to market. So SDV is going to be the game changer in integrating various technologies in a seamless way, but also in a faster way. Does it answer the question?
Gentlemen, you did raise an hand, but I see my fellow is already standing. It says announcing the end of my session. I had to close it. So before I end, I have one request. Give a big round of applause to my panel. Thank you
very much, KSV.
Keeping a session post-lunch not easy, and thank you for an excellent hearing. And look forward to have this conversation. And we'll get them back soon and say that maybe we'll take your question that time first, whenever you do it, and wherever you do it, and take it forward from here. Thank you all.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.